Our team name is Spooky SAS, and our product is the Halloween Suspenser. Our problem is that Halloween this year is being a little bit not the same as normal because of the pandemic that is happening. So Halloween normally you go to house and trick or treat, but for social distancing you're supposed to stay pretty far away from people. So our problem is, how can people trick or treat and how can people pass out candy with still following the social distancing guidelines?
Some of the people that would be interested and invested in this would be trick-or-treaters or parents giving out the candy, as well as us, the hungry college kids. Some of the criteria that we look at is the safety of the product, the visibility, that we can accomplish it, as well as the effective use of the Arduino and the theme, which was our aesthetics. Our specifications that we were looking at more specifically was how to be socially distanced for Halloween and also stay pumpkin themed. Some of our constraints were that it needed to be less than $40, as well as we finished in the span of 2 weeks and used the Arduino with one sensor and one output, including complexity and originality.
When we were looking into existing solutions, we found a video of a dispenser that used facial recognition software to dispense one piece of candy per person, and it used a Raspberry Pi. It used a whole bunch of really sophisticated coding. We also found a more simple catapult that was not originally made for candy, but could be made to throw candy from an acceptable distance for a socially distanced Halloween.
In Design A, we are using a proximity sensor to detect when a trick-or-treater is near. Then if someone comes close enough, music will start playing from the buzzer, the LEDs from the pumpkin's eyes will turn on, and the candy gets dispensed from the bottom of the pumpkin.
For B, I liked the idea of the catapult. I thought that it could be a little more simple than what was on the website. So what I was thinking was the Arduino would just control the mechanism that would release the catapult, and it could be good for just launching candy at trick-or-treaters.
For Design C, it was using the idea of a gumball machine with an added component of a sweeping arm. Essentially, there was a hole at the bottom, and this arm would be able to rotate, which would push candy down the hole. And then D uses more of a slot machine or door mechanic, where it would open, and then candy would be able to pour out.
Based on our decision matrix with a criteria of safety, spooky theme, feasibility, and most effective use of the Arduino, Concept C was ranked highest. For this design, we used a button as our input and a servo motor with a door attachment as our output. Simply press the button and the door attachment will swing open and dispense candy, and then retract after 2 seconds. In our final prototype, we wanted to add additional complexity, so we incorporated a buzzer to play spooky music to draw people's attention, as well as 2 LEDs which light up when the button is pressed.
So how the final prototype works is the buzzer plays a creepy Halloween song on repeat. Trick-or-treaters come up and press the button 1 time, 2 LEDs turn on, and then the servo door swings open, which dispenses candy for 1 second, and then the servo door retracts, and then music keeps playing on repeat.
Welcome, my name is Andrew Hitcho with Spooky SAS Productions, and our product is the Scary Candy. And let's give it a go. We have our trick-or-treater Wyatt. Simply press the button, the LEDs will light up, and then you got your candy. Happy Halloween.
For performance of the product, we think it was effective in allowing for trick-or-treaters to have socially distanced Halloween, as well as keeping that spooky theme of a pumpkin. We were also less than $40. It only cost us $35.96. We also used more than one output, having 2 LEDs, a buzzer, and a motor. We only had 1 sensor though, which was a button. Our design, we think, was complex and incorporated code from the Halloween movie soundtrack, which was an interesting and spooky theme. It was also original in the design because people generally don't think about putting a pumpkin there. And I think it would meet the stakeholders' needs and allow for trick-or-treaters to have a socially distanced Halloween.
In our code, the variables that weren't changing were the servo signal, the button pin, and the two LEDs. The servo was attached to our servo pin. We then used the pin mode function to define the button as input and the LEDs as outputs. If the digital read of the button is high, then the servo motor rotates to 90 degrees. And both LEDs turn on, and then a delay of 2 seconds allows for the candy to dispense. And then the two LEDs turn off, and the servo door retracts back to 0 degrees. For the buzzer function, the constants were the speaker pin, number of tones, and each note with their corresponding frequency for the Halloween song. Then the tones are arranged in the order of the song, and then the song constantly stays on repeat.
Within the mechanics for the design, we had a base and a door, as well as a button. The door could have had compression failure, as well as the tape having tension. The button also having compression, and the base having compression, that coming from the pumpkin having to sit on top of it. I also played with the idea that there could be possible shearing as the pumpkin was resting on it, interestingly, where it could begin pushing the sides that were holding it up outwards, and then the base trying to keep steady.
For the circuits, we have the Arduino, which is connected to its main outputs, the servo, the buzzer, and the lights. So for the server, it's connected to ground and power, but then it's also connected to a digital pin, which is where it gets its code from. And the other outputs, the buzzers and the two lights, are also connected to their digital pins for the code and ground. And the button controls whether or not they get their code and power.
So some improvements we wanted to make in continuing the engineering design process. We noticed that the pumpkins often rot, and mine rotted pretty quickly. So we'd rather have candy like not be in a pumpkin. And then we also thought we could use a 3D printed container to house the Arduino breadboard rather than like a flimsy box. And also possibly use an ultrasonic sensor. We would change that by adding a transmitter so we could like place the lights inside of the pumpkin rather than just be on the breadboard, and have candy come out in a chute rather than a trap door. And we thought our final prototype would be in some kind of compact box that houses everything, and then also is more creative and artistic to entice people to buy the product, and of course has the LEDs inside the pumpkin.
This is a little sketch of what we think the final product could look like. We think that it would be creative to incorporate gourds to hold up the pumpkin, and it may be difficult to see, but there are little LED bubbles for where they would be in the pumpkin. Some of the takeaways from Module C is that we need to learn how to organize better for team design plans and management. We learned how to put in more inputs and outputs to add complexity. We also learned the errors that can happen when creating a product, as well as the importance of going to office hours and lab hours to be able to use our resources. We also learned a better understanding of the coding and came back with expectations versus reality. And that's the websites we also use.